what's going on. Alright? So you have a car going on, and it starts going, and it's accelerating at 2 meters per second squared. And then this distance that ends up falling is 10 meters. We're looking for this distance here. And that's what we know. Okay? Cool. So first, I'm going to figure out what's happening while it's accelerating. I'm going to start with the first situation that I have available to me. So on this balcony, I don't know if that's how you spell it, but whatever. 0. So it starts from rest. That tells me that V naught is 0. Then it goes, acceleration is 2 meters per second squared. And the distance of the balcony is 3 meters. And I want what the V horizontal is equal to, so I can give it a shot as to figuring out what this distance is that it shoots off. I know I'm going to need that, right? So I have these three. This is what I want. This is what I don't care about. Go to this chart. Hey, this is what I don't care about. This is the equation I use. Cool. So that means that we got V squared is equal to V naught squared plus 2AD. V squared is equal to 2. This goes away. So 2 and then 3. So now I have V horizontal. V horizontal is 3.464 meters per second squared. Meters per second. Does anybody have any questions up to this point as to what I did? Yes?
Why did you, since we're not very concerned about time in this
Yes.
problem, why did you choose the time equation?
I chose the time equation. The way this chart works is that the time equation is what when this equation doesn't have time in it. So that's what's exempt from it. That's what I want exempt from it.
Oh.
Okay, that's how that chart works. This x means it's not in there. Okay? We good?
So you're saying that if there's a variable that was y exempt, then that means that could be a good equation to use
Yes.
when it comes to it?
Absolutely. If I know V naught, A, D, and I'm looking for T, I don't care about V. I go here, I look on the left side, V, that's the equation I use. That's the way you figure this out, is figure out what you got, what you're looking for, and then the fifth one, I don't care about. Cool? Alright. So now I know V horizontal is 3.464. If you can't see it, that's okay. It's just for my reference, because I got to erase this. Okay. Now where do we start? Okay, so now we have, this is basically a projectile question of dealing with only a horizontal velocity. Now, so that means that we can split this up into the fall. Now we're dealing with the fall, and it's got the horizontal and then the vertical. Okay? And because we know horizontally when something is going in the air, it doesn't have what? Shout out, I don't care. What does, in a projectile, when you're going horizontally, doesn't have any, there you go, acceleration. Perfect. So, dVt. That's all I care about. so I know that the velocity is 3.464. That's all I know so far. Then we go to the vertical. Now this, we got a good amount of stuff on. Okay, so acceleration is 9.8. Not all of you have been to my office hours, so here's my spiel about gravity and whether it's negative or not. Okay? If it's going down, if it's falling, gravity is helping it move. That means it's speeding it up. That means it's positive. If it's going up, gravity's working against it, it's negative. Think of it visually. Don't worry about if it's negative or positive in the equation. Think of it in terms of what is actually happening visually or in real life. Okay? That's how I always do it, and in that way, if you draw it out, you never get it wrong. Okay, so we have three things, and we don't have two. We could solve for either of these two, but which one do we really want to solve for? We want to solve for t, because as we know, this t is going to be the same as that t. Because something can't fall a certain distance and then shoot out a certain, it just can't end up here at two different times. This doesn't make sense. Okay, so we don't care about this guy. Over here, v, we use this equation, d equals to v naught t plus 1/2 at squared. That means that we have 10 is equal to 0 plus 1/2 9.8 t squared. Right? That means that this t is going to be 1.4285. Sorry that this is messy. I hate chalkboards. 1.425 seconds. Okay? Now usually I always write units, but because I'm trying to hurry for you guys and I hate chalkboards, not doing that. But try and write that because it helps. I solved a lot of problems that I didn't know what I was doing because I looked at the units. You have a question?
Sorry, did you use the middle velocity equation?
Yes, I used the one without final velocity. Done. Cool. Alright. Now I know this t, bring it over here. D is equal to this v times this t, so 3.464 times 1.4285 is equal to, where is it? 4.95 meters is equal to d. And hey, that's the answer. Cool? Any questions? Okay, I didn't write it out. Alright, so this t is brought over here. Nobody has a question with that, right? The t is the same. So then now I have v, I have velocity, I have time, and I know this equation d equals to vt in the horizontal because there's no acceleration. That means just multiply it to, you get 4.95. Cool? Yes?
Why is the initial velocity 0 if it leaves at a velocity of 3.46?
Because this is only horizontal. It is not going at all down or up at all, and this is the vertical that we're addressing. Does everybody get that? Cool. Moving on to